Hello, I am Mohamed Aissi, a second year PhD student at Sidi Mohammed bin Abdullah University. I'm here today to present you our work, Big Data Allowing Next Generation Fish Farming, and this according to the plan. First, we're gonna start by an introduction, then we're gonna move to the data lake architecture. After, we're gonna see how can we apply big data techniques in fish farming domain, and our proposed architecture. Finally, we're going to see conclusion and perspectives. Big data analysis has been used in various industries such as banking, insurance, medicine, industry, and marketing. Despite all the success that big data has achieved in the mentioned fields, it started being applied to agriculture only recently, but not in the fish farming domain. Moreover, the Food and Agriculture Organization of United Nations has affirmed that population is growing by 30% until 2050. Consequently, food production must be increased by 70%. So, to handle this increasing demand, and according to some agricultural specialists and corporations, applying big data to fish farming domain could increase the profits and the production quality. Now, let's move to the data lake architecture. Before we start, we can distinguish mainly between two data storage architecture. The first, which is the traditional data warehouse, which relies on the ETL process, which is extract, transform, and load. And this gives us the schema or write concept, which means we define the schema before writing the data. The second concept, which is the data lake architecture, relies on the ELT, which is the extract, load, and then transform the data, and this gives us the schema or read method, which means we define the schema until we want to read our data. So, as you may see here, the data can be retrieved from many sources. We can have streaming data, file data, relational data, and this data will pass across different zones of our data lake. First, the transient zone, where we can ingest, tag, and catalog our data. Then we have the raw zone, where we can apply metadata, protect sensitive attributes. Then we have the trusted zone, where we apply some data quality inspections and validations. Then we have the refined zone, where we enrich and automate our workflows. And then comes the data conception phase, where we can expose the valuable informations that we extracted from the data, either by the data visualization tools through dashboard, for example, or generating some reports, or even doing some data or predictive analysis. Now, let's move to how can we apply big data techniques in fish farming. The first step is in this process is to identify the potential data source and the data types that may be generated. In our case, data can be retrieved from IoT devices, and here I'm talking about sensors, internal or external files as CSVs, images, PDF, or something like that. And then we have the APIs. Then we move to the second step, which is the data collection. As we are using the data lake architecture, the generated data should be directly stored. Then we can proceed to some verifications to make sure we have stored the required data with the best quality. And then comes the data consumption phase. It is the most important step in this process, since it allows us to extract valuable information from the previously stored data, and this will help in decision making for fish farmers through insights, reports, or even predictive analysis. Now, Let's see our proposed architecture. The first phase, which is data acquisition, we may have data coming from three different sources. The first data source is the IoT devices. It is the data generated by the implemented sensors. We can have information about the pH, humidity, temperature, pressure, or something like that. Then we have the APE data. It will provide the external data as weather, price evolution in the market, market demand, etc. Then we have the manual files. It is the data generated manually by fish farmers and stored as CSV, text, or even images. Then we have the data management phase, where we have three steps. First, the ingestion. At this level, data is ingested to our data lake zones, and it is ready to be processed. The second step, which is processing, data being processed by applying business rules and doing the required calculations. And then comes the storage phase. So here, before storing the data, we pass it through some data quality checks or verifications. Then we keep it ready to use. The third phase, which is the data conception. So all the data available in the data lake will be used to extract valuable information through dashboards, reports, or doing some predictive analysis. So, integrating big data techniques in fish farming domain will not only increase the profit, but is also a key element for natural resources management, like water, land degradation, etc. Big data will allow fish farmers to take precise decisions based on multiple key factors, which was very difficult to handle using traditional systems. Our future works are focused on providing an advanced end-to-end fish farming system, including the proposed big data architecture. Thank you for your attention.